Hello, everybody. I'm Geoffrey the Smet. 18 years ago, I started an open source project to solve complex planning and scheduling. And so me and my team have not been doing nothing else since. And our technology is used in production all across the world.
Hi, everyone. I'm Tom Coles. I'm one of the leaders of the Belgian Java user group, so very happy to be in France today. I'm a Java champion. And who was in Luc's keynote this morning? Because I want to say we created these slides a few weeks ago. I didn't know. I didn't know. So I'm a big fan of cats. We're also cat fans? A few people? Yeah, so this was my cat Goose. I tried to bring him this morning, but yeah, not very cooperative, right? And I'm so happy that as a fan of cats, that the internet has really embraced cats as like the feel-good subject, and that we have a bunch of pictures out there, as Luc also showed. Now, what Luc didn't mention, and I think he kind of maybe missed out on his keynote, is now we can generate as much cat pictures as we want. Because a cat sitting on a crocodile while playing a banjo, boom, super, perfect. A cat doing a stand-up comedy show in front of a crowd of impressed goldfish, boom, there you have it. Although, if you can see it, the goldfish on the bottom doesn't look all that impressed, so... And this is what could have been if my cat decided to come along. Then we would have just sit down, and the cat could have given this presentation, and then... sorry, that didn't work out.
Yeah, but is that really useful, right? You know, allowing cats to do presentations, is that what AI can bring us?
I wish so. But needless to say, GenAI is pretty awesome. It can do a lot of stuff. And I mean, it could possibly be the solution for everything.
For everything, you know, really? I mean, yeah, if you really read LinkedIn and social media, yes, AI will do everything, will solve every problem, will solve world hunger. But there might be a little bit of a hype going on right now, right?
Maybe you're just out of the loop, Geoff. Because we have these cool things like RAG, you know? Who's aware of RAG? Retrieval augmented generation, yeah, by now almost everyone is. You could also fine-tune a model. You could take a base model and train it some more specifically for your use case. You could even have agents that basically do all the jobs that you don't want to do anymore. Mm. And don't forget, the most important part about this entire thing is it will only get better.
Yeah, sure.
You know what? You're still doubting. You know what? You tell me something that LLMs and GenAI can't do.
Yeah, well, of course it will get better, but that doesn't mean it will get better at everything. There are certain things it might not get better at, right?
Illuminate me.
Yeah. So, for example, planning problems, right? No big surprise, I guess. That's the thing I'm focusing on. But I really have some objections there if it'll get better at this, if it is the right technology for the job.
Okay.
So,
convince me.
Yeah. So. Planning problems, first of all, what are planning problems? Planning problems is when you need to assign work to people, basically. So for example, in this case, we need to assign delivering these boxes to a number of houses, and we need to figure out for each packet which person does it, and then in which order they actually go to those houses.
So something like DHL or FedEx that deliver. Okay.
Yeah, and sure. Academically, this is called a vehicle routing problem, which you might know from studies like in the traveling salesman problem. Is when you only have one person, right? But and these kind of problems are actually quite hard to solve. And it's not just for delivering packages. It's also when people need to do field service technician jobs. For example, install cable or do maintenance on elevators or machinery and things like that, right? But there's many more planning problems, right? When you want to assign airplanes to flights, or when you assign people to those airplanes to do those flights, these are all planning problems, and they're all a little bit different. But generally speaking, they're all the same kind of problems. And of course, when you need to assign shifts to doctors, to nurses, to security guards, any kind of case where people don't work 9 to 5, you probably are dealing with a planning problem. And so my question is, can LLMs actually solve those? And just to give you one example, let's presume we have 7 days. Let's take a look at that shift scheduling problem. We have 7 days. We have 5 shifts per employee.
Okay.
So we have 30 employees. That's a typical department into a hospital. 30 employees that need to be assigned to their shifts, and that means we have about 150 shifts to assign. So for each of those 150 shifts, we need to figure out which employee is the right employee to do it, and then we get a solution.
Okay. I mean, that sounds easy enough.
So yeah, how can an LLM solve that for me?
Well, I think for LLMs, they should be walking the park. So let me be a bit more specific. We had LLMs that just generate the next token. We've built some things on top of it. We call that now reasoning models. These LLMs that can reason, you ask it a question and it starts thinking. And I think those can actually solve this.
Okay.
So I actually tried a couple of them. I'm going to show you some screenshots that I made because it reasoned for about 12 minutes. I can't reasonably let it reason live on stage unless you want to. That's an experiment for at home. But I'll show you some of the interesting things that actually came out of it. So a lot of Python. A bit weird for a Java conference, but it analyzed a bunch of the data that I inputted with Python. But it did see certain things like, hey, there's a couple of shifts, and there are some shifts require skills. So ambulance skills or surgery skills or ORL skill.
So what's ORL?
ORL is I can't pronounce the word, but it's basically nose, throat, and ears doctor. Okay. If someone can pronounce the actual word. It's ORL? Oh, what a blessing. So ORL. ORL. It's the same in French. Good to know, good to know. So it actually recognized from the data set that certain shifts require these skills. At some point, one of the employees, the LLM tried to assign it, and it started talking about Orlando because ORL is not only that kind of doctor, it's also the airport code for Orlando.
So do we really want that? Do you want somebody to do surgery on me for my ear infection who is actually specialized in the Orlando thing?
Maybe he lives in Orlando, I don't know. But as long so it makes a few mistakes, but you'll see. Calm down. This is just a reasoning. Then it started mentioning rule 6, but I only inputted 5 rules.
So now... So now the AI is actually making up rules for me?
Yeah, but you'd be surprised because it's actually a good rule. If you're trying to assign shifts, as you can see, it invented a rule 6 where it is trying to avoid a night to day shift. So when you have a night shift, that you don't, the day afterwards, have a day shift. I didn't add it as an explicit rule. Yeah, but the LLM reasoned it. Like it's a reasonable thing to ask.
So you made a mistake of forgetting to input that rule, and it did it for you. So this is actually a good thing.
Yeah, it's a good thing.
I agree. This is a good thing.
And in the end, Geoffrey, you can say it can't, but I actually made a schedule. There you go.
Yeah, okay. We're assigning Beth Fox, we see, to that Monday morning shift, the first row there. Yeah. Right, that's an ambulance shift. I presume she has the right skill for that. Yeah, looks pretty good. But this is only the Monday, right? We had more days, right?
Yeah, you said 7 days.
Yeah, we had a 7-day schedule.
But like any developer, I try a smaller data set first, and then I say it works. I go to my manager, I say this proof of concept works. Yeah. We ship it to production, and then we see what happens on the larger data set.
Okay, so you just put a deadline, and you just fix that later, right?
So you're basically asking me, can a reasoning model do a realistic schedule?
Yeah, like the 7 days one. Yeah, can it do that?
I got this message. Sorry.
Okay.
So when I tried to do the full data set of 7 days, LLM, I tried a bunch of different providers, by the way. Some of them just errored out like this. Others just stopped saying anything. Like you ask a question, and like a nervous student during an exam, they just, you know. So that didn't work. Eventually, it did say, hey, I assigned all 150 shifts to these constraints. So the 7 days, it worked.
So maybe I should stop our project right now then, because it can solve it for us.
Maybe, but I must be honest, it was slightly over-optimistic because I took the result and I tried to visualize it, and this was the schedule. So as you can see, very colorful.
Is that a good? Well, the red doesn't look good to me.
The red means that it actually scheduled someone when they are unavailable. So Amy King is working 2 shifts right after each other when she's unavailable, and Dan Poe is apparently working non-stop with a few stops. So it assigned everything perfectly. 150 shifts are assigned. So
and also some of the skills there I see, like we were sending a nurse when we need a doctor. Not quite sure if I want that as a patient.
Yeah. There's one shift that requires a cardiologist, and so cardiologist for the heart, and it's only a doctor that's assigned to it. So I don't think I want heart surgery from someone that's not a cardiologist. So needless to say, it didn't work on the bigger data set. So why? It's always an important question, especially people sometimes have a bit of fear, like this is going to take my job, blah, blah, blah. But whenever you see something that LLMs can't do, that's a really interesting space to look into now, both for interesting research, but also that kind of job security. If this thing can't do it, then we're safe, right? So, Geoff, tell me, why can't these LLMs, why do they fail on these kind of cases?
Yeah, well, the thing is, solving a planning problem, a small planning problem, is a lot very different than solving a bigger one, right? And because scheduling is actually a sequence of decisions. And it's not a sequence of decisions. Sorry, scheduling is not a sequence of decisions. And let me just try to explain that a little bit. So here we need to assign 3 shifts to 3 people. So we have an early shift, a day shift, and a late shift. And you can see these actually have different skill requirements. The early shift requires intensive care, the day shift requires oncology, and so forth. And you can see when they start, the early shift starts at 6 till 12, and so forth. Now we have a number of employees who can do those shifts. And you can see they have different skill sets themselves. So for example, Anne has intensive care and emergency room skills. So we need to now decide which goes to which. Now, we could actually do this one by one. So we could just say, we are taking the shifts in order as they appear. So we start with the early shift, then the day shift, then the late shift. And we could just see this as 3 sequential decisions, right? And sounds very easy. We take the first shift, we look at what are the options there. We can see we can assign the first shift, that early shift, to either Anne or Carl. So we'll just assign it to Anne, right? That's good, because Anne has intensive care, and the shift requires intensive care. Now we can only assign 1 shift per person per day. Okay, so we now look at the second shift, the day shift, and we assign that to Beth. Beth has the right skill, right? You can see that. She doesn't have any other shifts that day, so we cannot assign it to Anne. Looks good. Now we look at the third decision, late shift, and we assign this, we run into a small problem.
You can't do that. Carl doesn't have emergency room.
Exactly, right? He lacks the skill.
So this is a simple example. You could have just looked at the late shift before you assigned the day shift.
Yeah, but that's just because there's only 1 shift after assigning that day shift. So we could have done this. As a human, we will look a little bit further than that, right? And the LLM could do this too. But imagine there's 100 shifts around that, or 174 other, or 147 other shifts behind that, like we have in the data set with 150 shifts, right?
That becomes a bit harder to.
Yeah.
Okay.
Now, you could easily fix this, right? You could just
switch them around.
Yeah, so it's that easy, right? So, like you said, if we look a little bit further, we could just switch them around, we get a good solution, right? So, and so how hard can it be? But the problem is that we have far more shifts. And the next day, imagine for a case that the next day we actually have 2 morning shifts for oncology, right? Now, those 2 shifts can only be assigned to people with the oncology shift skill.
So Beth or Carl?
Yes, because they're the only ones with those shifts, so we need to assign them to them. There's no way we can assign them to Anne, and we cannot assign them both to the same person, of course. As far as I know, persons cannot be in 2 places at the same time, not even nurses, right, or doctors. And so, okay, but here's the problem. Now there's only 8 hours between that late shift for Beth. Beth ends at 10 o'clock in the evening, and her next shift is 6 o'clock in the morning. So she only has 8 hours in between, so that's less than 10 hours.
Yeah, I don't know about you. I like my 8 hours of sleep. If I need to go from the office to home and back to the office, I need more than 8 hours between 2 shifts. So.
Yeah, and also food is typically interesting. Yeah. So
details.
Details, yes. So anyway, how do we fix this? Well, it's quite easy, right? You just take that late shift from Beth, you move that to Anne, because she can also do emergency room. Then you take the early shift from Anne, who cannot do that shift anymore because she's doing the late shift. You move that to Carl, because he can also do intensive care. And then you take Carl's day shift, and you move that to Beth. And voila, it's that simple.
My head hurts. You made it maybe look simple, but this, because 2 extra shifts entered, you actually had to change your entire schedule.
Yes. You change one little thing and the whole problem changes. You cannot just focus on one corner and fix that, optimize that, and presume that everything else is correct. You cannot cut this into pieces. It's one big decision, one big planning. I would not even call it a decision. You cannot cut it up into a sequence of decisions. And this is what makes these problems so much fun, I would say.
Okay.
Right. So the thing is, of course, this was shown with about 5 shifts in the end. In reality, our small data set, 30 employees, 150 shift assignments, so how many ways can we schedule those 150 shifts to those 30 employees? And just to give you an idea, we can take that first shift, and we can assign that to one of those 30 employees. So that's 30 different ways we can assign that first shift to somebody.
That's kind of ignoring like constraints like
Yeah.
skills and such, but okay.
Yeah, yeah. Now, this is just, we don't know all of the, normally you have all the skills and you can calculate that out. What you might see is in 50% of the shifts, you cannot, 50% of the employees you cannot assign to that shift, which means you would have maybe 15 options. But in the math we'll do, if that's 30 or 15, you'll see that really doesn't matter.
Okay.
So now what happens when you have 2 shifts? How many ways can we assign those 2 shifts to those 30 people? Well, that's actually 30 times 30. Now you could again say, but wait a second, what if you assign those 2 shifts to the same persons? We don't want to do that. Well, they might actually be on different days.
Yeah, different days or different weeks, or depending on how much you're planning. Sure.
Yeah, so that would actually be fine. So the number of ways you can assign 2 shifts to 30 people is 30 times 30. Now, when you have 3 shifts, that becomes 30 to the power 3.
I'm beginning to see a pattern here.
Yes, yes, yes. And so when you have 150 shifts, that's just 30 to the power 150. That's the
I've never seen a number like that.
Yeah.
Could you elaborate a bit more? Because that number 30 to the power 150, what does that even mean? Like, it doesn't fit in my head.
And that's all of the options. So that means, what if we could just go through all of the options, brute force, and pick the best one, right? Or what if we or LLMs or humans or right? And the thing is, 150, like 30 to the power 150, that's actually 10 to the power 221, right?
Still, give me something to relate to, because this...
Yeah, well, in the universe, the number of atoms in the observable universe is 10, or the minimum number of atoms in the observable universe is 10 to the power 80. So this number is just about 141 more zeros behind that number.
Only that.
Yeah.
We should be able to brute force that. Right?
Yeah. That will take you a couple of billion years. Well, actually, that would be quite fast if you do it in a couple of billion years, right? So even...
Okay. So brute forcing is not an option?
No. So you cannot optimize for such a search space, and you cannot do it by predicting the next token like LLMs do, and you cannot do it by reasoning like a human, right?
Yeah.
Now, humans do solve these kind of problems today, but they just don't know they do it actually very, very badly. We just hire more resources, more people, more machines, more vehicles.
Or it takes them like, for some people, this is a full work day.
Yes, that also
to schedule it. Yeah.
Yeah, but even then they don't just automate it. They don't optimize it.
So okay, I can sort of see, especially where we are now, LLMs can't optimize schedules, but
yes.
But I think AI can. And I know for some people this is sort of shocking, like, yeah, but this is AI, right? Yeah, but AI is actually much more than what we normally, what people on the street talk about AI right now, they mean GenAI, a very narrow subset of the entire AI ecosystem. And if we zoom out a little bit, we can actually see that there's more to the circle being machine learning. And I know that Luc also alluded to this, like we had machine learning and it can do awesome things. Basically, we have a bunch of data and we throw it at the machine and it learns something. And there's very valuable things in there as well. But then the question is, kind of alluded to that, so you give more data to the system and it learns. Can machine learning solve this? Because machine learning is awesome. And honestly, before you continue, does anyone know what this is? Sign language. You can actually, if you have enough examples, you can train a sign language interpreter just with a camera, if you give it enough examples. So it's a different example than 100,000 cat pictures to recognize cats, but general it's the same. You can train these things to do awesome things. But can it also optimize the schedule that you're talking about?
Well, in my experience, no.
Okay, we're going to need a bit more than no.
Yeah, fair. So these things learn from data, right? So they can actually, if they had all of the possible solutions to our planning problem available, they could learn all of that and capture that. But it's fairly easy to see that because you cannot cut pieces out of a planning problem and just learn that piece, you have to learn the whole thing, because you cannot cut them up, you cannot partition them, that they basically would need to learn these billions or 10 to the power 200 possible solutions, and they just have petabytes or terabytes of data, so they have far less data. They can not even do 1% of 1% of 1%. So they cannot learn the solutions by heart, and there's not really clear patterns on how to use those to solve those problems, right? So they the data simply isn't there, and they cannot learn from. There's not enough data, basically.
Yeah, and as you've learned during the keynote, if there's only like 2% that's incorrectly calculated or predicted, and then you saw our example where the schedule completely changes if only one thing changes, then it already gives an impression that that won't work.
Yeah, and if you assign one nurse to a doctor's job and you get surgery by a nurse, that's a big problem. So there's no room for breaking one or two hard constraints when you solve a planning problem. You need to solve all of them or you throw it away. That's the thing. It's all or nothing, right? So all of these things are interlinked decisions. It's a little bit like when you play with a Rubik's Cube, right? You look at this Rubik's Cube, you go like, oh, I just need to have a yellow extra square on this side, and you start moving this around, but on the other side you had a very nice, most of the green already, and by adding that yellow one on the front side, the green one is completely broken. And this is the same thing there. You change one little thing and it starts breaking all over things. It's spaghetti. You pull on one wire and everything else starts moving.
Okay, that sounds sounds a difficult thing to solve. So GenAI doesn't solve it. Machine learning can't really solve it. Then what can?
Yeah. So AI is more than machine learning, right? Okay. People tend to forget that these days, especially the younger generation. But there's actually a lot more AI techniques beyond that who can solve particular problems, narrow problems, very simple, very similar to what Luc talked about, and they're quite good at it. And so one of these is mathematical optimization. It's a piece of technology that already exists for 30 years, and it can solve planning and scheduling problems.
So you're telling me that after years of not seeing these kind of witchcrafty things, I need to do this again?
No, that's the old way. You can still use technology that does it this way, but these days we call it planning AI, and there's tools that can actually allow you to code your requirements with just normal code on normal domain objects in Java, and where you just solve the problem. And of course, surprise, surprise, the technology I started a long time ago, and we are building on is, of course, one of those, and that's Timefold.
Okay.
Now, Timefold is an optimization algorithms in domain code. So in your domain code, you specify what your input is, or how it looks like, your nurses and your shifts and things like that, or your vehicles, and then you can use code to actually decide what you want to optimize and what you want to optimize for. It's fully open source, the solver. It's under the Apache license. You can use it. You can do what you want with it. It's on Maven Central, of course, and so forth. It supports Java. It's fully written in Java. You can run it from Java. You can run it from pure Kotlin if you're into Kotlin. And you can even do Python if you really want to.
But then Python is just a wrapper around the Java code, right?
Yes, technically underneath. That's how we actually maintain the speed. And it works quite well if you do it purely in that language. We have in our examples, we also support Maven and Gradle, so whatever technology you use. We supported Spring, Quarkus. We We have extensions for that. It all just works.
That's all the talk show. Finally,
yes.
I was going to say, that's all the talk showed something.
Yes. So here we go. So what we're going to do is I'm going to take one of the quick starts, which is the employee shift scheduling case, and we're going to use this to assign a number of shifts. So in this case, we have 133 shifts. You can see here we have a shift for ambulatory care, which has some requirements. Let me zoom in on that a little bit. Here we need a doctor. We need that doctor, and we need that from 6 a.m. until 2 p.m. And we now need to assign this to a person, right? And if we go to the employees, you will see we have a number of employees. So we have Elsa Green, Elsa Lee, and so forth. These also have skills. So for example, Elsa Lee has cardiology and the nurse skill. And then we need to assign those shifts to those people. And you can see
they have some times when they want to work, that's the green ones that they really like, I have nothing else to do, just assign me this shift. And there's places where they're undesired, that's the orange, that's actually, I actually don't want to work that time because I want to do something else, but if that's the only way, then sure. And unavailable is like they're on holiday or really fixed leave.
Yes. So if we now go to the code, I'll just show you behind that. So this is the Timefold Quick Starts repository, which you can download and play with. And one of them is the employee scheduling case. So that's the one we're looking at today, which we were talking about. And so I'll just show you a little bit what's in there. So we have a couple of domain objects. The major two ones are employee and shift. So this is the shift class, as you can see here. So we have a shift which has an ID, has a certain start time, a certain end time, which is a date time, of course. You can add a location if you want to. There's a required skill. In this case, we've kept it simple. The skill is just a string, but more in elaborate cases, that would actually be a skill class with some properties. And then, of course, we need to assign this to an employee.
So what's that planning variable thing?
That's a good question. Now, when we start out, we're going to give it those 133 shifts or 150 shifts. And for each of those shifts, we need to assign an employee. So the employee will actually, the employee reference will actually start out as NULL, null, right? And then and then Timefold will actually assign each of those shifts to an employee. It will pick them from the list of employees we give it. And but it needs to know what it can change. And that's why the planning variable there. That's basically saying, Timefold, I give you the, I allow you to change that. Right. Okay. And then whatever has a planning variable also needs to be a planning entity. That basically means this class somewhere has a planning variable. It's like an entity class in
so it sounds like JPA. Yeah.
Yes, very similar. And then of course we have employees. An employee looks like this. We have an employee with a certain name, which is a list of skills. Set of skills in this case. And also you can see the availabilities and unavailabilities and things like that. The ones we saw in green and in orange and in red earlier.
Yeah.
We're going to send this. We're going to now, of course, we know what data, how the data, the structure of the data that comes in and comes out looks like. But how do we actually tell it what to do, right? And that's actually in the constraint provider. So here in the constraint provider, I'm just going to. This is all of the constraints we want to do, and just for fun of it, I'm going to just disable all of the constraints for a second.
So there's no constraints anymore. So
yes.
What happens then? Show me.
Yes. Okay. So here we go. So I'm going to just assign all of these shifts. So I'm going to click the solve button. Now this button just calls timefold.solve, and it just starts solving it, and it just assigns everything. Problem solved. We can go home.
Could you please go to the by employee tab?
Yes,
I think there's a small issue.
That will look better than this tab.
That looks better than this tab. Yeah. Yeah. Perfect schedule. Elsa Green is going to work really, really hard in all the things that she actually also can't do.
99% of the people are happy with the schedule.
Okay. What about the 1%? I'm pretty sure Elsa. But the problem is, if 99% of the people are happy and one person is really unhappy, they quit, and then the 1% keeps moving. So I think we need to fix this a bit.
Maybe. Okay. So we don't want to have more than one shift per day, right? Let's start with that. So I'm just going to add this constraint for a second. We'll go back here. Here we go, and we'll solve it. So let's see what happens now. And I'll actually bring it also by employee again. So what we see here is now the shifts are more spread across the thing, and so Elsa could actually do this, right?
Okay, I think we need a few more constraints.
Yeah. For example, we're actually the first shift we're assigning to Elsa here is a doctor shift, and again, she's a cardiology nurse, so that's not good, right? So let's fix that, and let's actually go. Oh, let's actually go there. So here we go. I'm going to add that skill.
Could we maybe have a look? As now you're just uncommenting methods. What are these methods doing?
Yes. So here's the method, right? So this adds that skill. So what we're doing here is now what you might have expected here, maybe just a for loop, right? Go for each of the shifts. If the shift has the required skill and that person doesn't, the assigned employee does not have that skill, then we're going to tell it it's wrong, and you could do that. This is a more functional approach. I'll first explain how it works, and then I'll explain why we want to do it this way. Very similar. We basically say for each of the shifts, we're going to. It's like a constraint stream. It's like a stream, a Java stream, right?
It's a mix between a Java stream and SQL syntax, basically, from blah, 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 filter something.
And the reason why we do that is so we can actually do incremental calculations, which means that once, as the solver is actually looking for better and better solutions, it can only calculate the delta between two solutions, such that it doesn't need to recalculate the whole solution as things change. And this makes it not a little bit faster, it makes it up to 1,000 times or even more faster. So it's a really, really big, important thing to do. But the cool thing is that that whole delta calculation, it's done for you. The only thing you need to do is use this fluent syntax. And so what we do here, we basically say for each of the shifts, I want to filter out all of the shifts that are basically bad, that are do not have their required skill. So what I do here is I look like, okay, if the shift has a You can see the shift required skill here, right? We're going to check if the shifts employee in their set of skills actually contains that required skill. And
so that's some pretty basic Java code, just checking
yes.
if something's in.
Yeah, you can call any piece of Java code here, which is the cool thing, which you know, with that mathematical formula, it's actually a big problem, but here you can call a method and so forth. Please do not call an external service. This is called 100,000 times per second. If you call an external service, that will no longer be the case, right? You will not get a good solution.
Accidental denial of service attack.
Yeah. And then we say if we don't if that employee does not have that required skill, right? Then we're going to penalize, which is basically mean like we tell the solver don't do that. We can also reward it if you want more of this, but let's not do that here. And we're going to say it's a hard constraint, which means you really need to do it. It's not optional, right? If it's a soft constraint, means you can do it. We want you to do it. We want you to avoid it. But if it's a hard constraint, it's like you must never do this, right? Very simple.
Could we maybe show the difference between a schedule that only solves the hard constraints and then the soft constraints, just to give a better impression?
Yeah, of course. So, then I should actually enable all of the other constraints too. So we don't want overlapping shifts. We want at least 10 hours between two shifts, if we remember from the beginning. And we want to make sure that when an employee is unavailable, that they don't get assigned to that. So if we go back here, right, and we solve this. Here we go. What we will now see is that, first of all of the skill requirements are green, so nobody's doing any work that they cannot do. So I'm not getting, when I need a cardiologist doctor, I get a cardiologist doctor and not somebody else. And you can also see when people are unavailable, which is the red parts, they don't get assigned.
Yeah, but it can still be a little bit improved, right? So this is a schedule that you can work with, nothing is broken. But you can see that there's quite a few people that have to work when they actually don't want to work, when they have like an undesired period.
Yeah, and what also see here is Carl, he's not doing a lot of work, so this doesn't really look fair.
Carl isn't doing a lot of work?
No, Carl's not doing a lot
of work. Oh, on the bottom, wow.
So this doesn't really look like a fair schedule to me, right? So what we're going to do is we're going to say, okay, when you don't want to work, let's avoid it. When you want to work, let's try to give you work. But more importantly, let's balance out the shifts. Let's make it fair. And this is where it gets interesting, right? There we can do fairness across work, but also fairness on who gets weekend shifts and so forth.
Show me the result.
Yes.
I'm curious.
Yes, here we go. We solve that. Now what we see is that if you look by employee, that we do sometimes still assign people to those unavailables, but you can see that we avoid it, and as it solves longer, and if we give it more CPU time, it actually managed to not assign them during those times. And if we look down a little bit, what you will see is that Carl is actually working. Probably if we scale out, you should see that. In the long run, it's fair, right? Yeah.
Okay.
Okay.
So one of the comments you gave me when I was doing the LLM stuff was, this is a toy example. It's not big enough. You couldn't do all the days. This is still only 130 shifts, not a big set. Could you show me like a bigger data set? Yeah.
So we have a larger data set. So remember the one with 150 shifts, that was already 10 to the power 200 combinations, right? So this data set is 900, almost 1,000 shifts. So this is not a billion times bigger, but like a Google times bigger, probably even more than that, right?
Okay.
So
show me.
whatever, right? It's just big math, right? So okay, let's solve this one. So what we're going to do in this one, so same thing, we assign all of the shifts. Now, what you can see here is that right now we still have a couple of hard constraints broken because it's actually a very difficult data set. It's not an easy data set. And if we click here on the question mark, we can actually get an overview on the solution we just had, a snapshot of that, to see, okay, what was wrong with that and what was good with that. So in this case, we saw we were missing the required skill for one case. So that's why that was the problem with that. We had one assignment where we had the wrong skill. And everything else was, we lost a couple of points, of course, on desired days, that we still had people working when they don't want to work. That's always there, like on Christmas. Nobody wants to work on Christmas. We will
But it is very explainable. You can go to put two of these schedules next to each other, and with this list, you can go to your business. Well, is it really a big problem that this person doesn't have the required skill? With nurses, it's probably going to be a problem, but in some other cases, it might not really be that big a problem.
Yeah, and then you can change the constraints specifically for those cases. You can play with that. You can make some of these more important.
And in the meantime, did it actually find a way? Okay,
so now it's feasible. So now, actually, if you look at it right now, it says everything's fine. All of the hard constraints are fulfilled, and you can see, more green checkboxes, which is what you want.
Okay, cool.
Okay.
So this looks very cool. Oh, like what other kind of problems can this solve?
Good question. Let me go to here. So,
if I understood you correctly, you model your domain. So you just do your Java modeling like you would do object-oriented. You add some annotations. You define these constraints in your SQL Java streams like syntax, and then you just click run, and it solves it.
Yes, and it's not just for shift scaling, right? So, like I said, actually the world is full of planning problems. Once you start seeing them, you see them everywhere, right? Vehicle routing, the one I talked about earlier, when you need to send vehicles across the country and you want to optimize, that's the vehicle routing problem. Maintenance scheduling, elevators, stuff like that. Order picking in warehouses and so forth. Once you go into industry, it's full of them.
There's one interesting one there.
Yeah?
Yeah, what is that on the second?
This one.
Yeah.
Conference scheduling. Yeah. For example, you can actually assign talks to rooms and to rooms and to time slots, like speaker talks, right?
Sounds familiar. So, if there any other speakers in the room, we're sorry.
Yeah. So, Timefold, Devox France was actually solved with the conference scheduler from Timefold. So, and that made us get the morning shift at the morning slot at the first day. So
we made the solver. We have no more control from now.
No. We don't. So there's no hard coding.
Other speakers that are unhappy with their slots, don't come to us.
Yeah. Whether it's bad, good or bad, right? Yeah.
So you've shown this cool stuff. LLMs can do the tools like this can do that. But what do we envision is the future of AI? Yeah. Now we've talked about these. You can actually see the circles on the resolution of this, on the brightness of the screen. But there's circles like artificial intelligence is the big circle. Within it is a small circle for machine learning, and then there's GenAI. And when we talk now about AI, mainly when people talk now about AI, they mainly mean GenAI. But that would kind of disregard all the valuable things that we would get from the outer circles. We've shortly discussed machine learning and the cool things that you could train there, and we've shown you Timefold with artificial intelligence. But I think the future is really in integrating those together. And of course, the obvious one is letting LLMs write the code for you. You know, it's Java code. If we can use LLMs to do that, that would be great. Now, we ran some experiments with Timefold, and we noticed that if you try to use ChatGPT to generate constraints, it doesn't work. So what we are currently working on, it's not public yet, is, of course, very low-hanging fruit, having a Timefold GPT. Now, let me just quickly show you what that looks like. So, in case you've never seen a custom GPT, on the left, you can configure it with a bunch of stuff, logo and such. I can't actually, there we go, that's better. You can give it a list of instructions on how you want it to answer. So I've inputted all that. I've also said refuse to answer any questions not related to Timefold, and usually it obeys that request. But most importantly, when you make a custom GPT, you can give it extra knowledge, so RAG, basically. And we've uploaded the entire documentation that we have, which is about 500 pages, give the PDF. And the results now are actually way better. So make me a constraint that will make sure that an employee has the correct skills for a shift. And when we asked this to ChatGPT, we often saw that it's inventing a bunch of stuff. But now, it's actually giving the domain as well. So, it's giving assumptions, which it should be. And shift assigned employees. It has a bit different names than than you saw in our example, but it did generate quite something correct, and it has even a breakdown of everything. So we noticed that our custom GPT runs a bit better than the normal one. So that's one of the ways that we foresee that we can use LLMs to enhance our form of AI, basically.
Yeah, as a coding assistant, basically.
As a coding assistant, yeah.
Yeah.
But also, you can ask it documentation questions, and it will find it. Like that, it's good at that kind of stuff, right?
Yes.
The second thing, and you'll hear this term. Who's never heard of MCP before? Never. A few people. Okay, so let me shortly explain it. MCP allows you to connect tools to an LLM. So, for example, if I open up Claude here, and I've written a small MCP server to actually connect to a piece of Timefold. And here it is. So it pops up as tools that Claude can use. So if I ask it, for example, the demo that Geoffrey gave us with nurses, okay, but I want a different use case. Could you give me a different use case?
Security guards, maybe? Where you... Because they also don't work 9 to 5, they also have shifts, they also want to have certain days off. It's basically the same thing, right? But yeah, different skill sets, I believe.
So I basically ask it, could you prepare the demo data, so our demo data example, but then use the security industry? Then I'd be happy to do so. Blah, 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 blah. It actually gives me different locations and skills, and I currently do not find a convenient way to zoom in, so I'm terribly sorry about that. And then I'll just say yes.
Crisis management, yeah. Interesting skills.
There he goes. And now it will actually call a tool that I've written. So that's just Java code. And when I say allow for this chat, it will actually go out to my MCP server that I created with Quarkus, and it will prepare the demo data. So I will actually go take this code for a second, because that wasn't fully integrated yet. And if I go here, plan, and I paste this code. See, now I have exactly the same demo that Geoff has, but now I have specific examples for the security industry. So there's cool ways to integrate all of this together.
The security room, the CCTV
security building, CCTV monitoring. The skills for the employees are different, so it's now crisis management, CCTV monitoring. So first aid is still a bit nursey, but the code for that will be online as well for this MCP server.
And I presume you're using things like LangChain4j or something?
No. This is an MCP client with Quarkus. So it's not LangChain4j.
Oh, cool.
So MCP allows you to add extra tools to things like Claude. And OpenAI has actually announced that they'll also support it for
but we could do it with LangChain4j too, right?
LangChain4j would be a slightly different integration, but so
same thing.
These kind of things can really make sure that in the future we will be able to integrate these different forms of AI, and each of them has their own strengths, you know? GenAI is very good at data extraction and making new data. Like I just showed you, creating new examples. Machine learning is very good at prediction. So in the examples Geoff gave, we had to upfront define we need 150 shifts. But with something like machine learning, we could sort of predict how much shifts you need.
Yes.
And that is a very powerful proposition as well. Yeah. And then, of course, you have planning AI, so the thing that Geoff showed before, that can really help with sketching. And combining all these things together will make the whole a lot stronger.
Yeah, 1 + 1 is 3, basically.
Yeah, 1 + 1 is 3.
Okay.
So to conclude, GenAI is awesome. I showed you my cat. I showed the cat pictures I generated. I think it's absolutely amazing. And there's so much more production-worthy stuff that you could do besides generating cat pictures. Yeah, but we need to realize that it can't do everything. So if there's something that you take away from this session, it's that there's a lot more to AI than just GenAI. So whenever someone says, I'm doing something with AI, try to check, are they just generating something with ChatGPT, meaning GenAI, or do they mean something in the bigger circle? And really investigate for yourself what kind of valuable things are in the other forms of AI that you could integrate together, because that's a really powerful thing to do.
Yeah, the right tool for the right job, basically.
The right tool for the right job, and integrating them together so it becomes 1 + 1 is 3.
Yeah, definitely.
Okay, that was our talk. I hope you enjoy.